Watch the ride.
Hey everybody, so I've noticed on YouTube there is an awful lot of videos about welding, and most of them are pretty in-depth and brilliant for helping you learn. Some people out there are really giving away some gems of information and great tutorials and stuff, and if you want to learn more about each individual type, then I suggest you go and find those channels. They won't be hard to find, the big guys. But I haven't really seen any videos where someone's just said what each basic type of welding is and why you might use it. You know, you may not want to know about the different thicknesses and the different types of steels and all that. You might just want to know how the thing generally works and what it is when you see someone using one of those machines. So this idea of this is, it is very basic. It's not going to have any great technical details in it. It's just going to explain how the process kind of works. I will add here that I am not a welding expert. I do welding for my metalworks business, where I basically make clocks and pieces of art that are welded. But with my welding, obviously no one's life is on the line. So as I say, I'm not an expert and I don't profess to be. And I'm not going to try and give you too much sort of expert information, just the basic stuff. I'm going to cover the 4 most common types of welding, although some of them are a bit old-fashioned these days. But I'm going to cover gas welding, MIG welding, TIG welding, and stick or MMA welding. This machine does both, so just understand that. And this does MIG, and this is, well, it's got no bottles, so it's not going to weld a lot. I'm going to quickly explain each type and show you an example of it working, just so you know, even if you see it on TV or in the films or someone doing it, you might understand what they're doing and why they're doing it, and maybe what they're welding. So let's get on with it. Okay, so the first type of welding we're going to talk about is a bit of an old-fashioned one at this point, but it is required for some jobs. I don't know too much about it, so I'm not going to say too much about it. This may not even be a welding torch. This may be for something slightly different, but the principle is the same. So welding as a basic thing is that you take 2 pieces of metal and then you want to heat those up until it starts to melt. Then you normally add another material, which is the same material of a slightly higher quality normally, with that, so you have a liquid pool that you push around and it'll penetrate, you hear that being said a lot, into the metal, heating it all up, and basically the weld becomes one. So if you chop through it, you might not be able to see anything, or maybe just a very thin line, but normally you can, you know, once you've sanded it, polished it, ground it, whatever, you won't even see the difference. It'll look like it's the same piece of metal. That's one of the things that really gets me about welding, is the way you literally can apply metal to metal and then remove it and put it back, and it's just very, very satisfying to do. So as I say, the most basic way of doing this is with fire. Although it's slightly more complicated than just fire. This would be oxygen and acetylene. There may be some other mixes people use, but you basically have a fuel and an oxidizer, oxygen, that basically gives you you've got these knobs to adjust the mix, and then you get a very clean, very, very hot flame, and that's what you can weld with. Gas welding, as I say, uses fire, so you're heating up the metal, then you're adding a bit extra in, blah, blah, blah. I don't know too much about it, but that is basically what it is. It's the very most basic type of welding, but we don't really use it these days, generally. So as I say, gas welding uses fire. All the methods we're going to talk about from now on create their heat by using electricity. So they all will have a few things in common between them, such as this, which is a ground clamp. Basically, this attaches to your machine. This attaches to the piece of metal that you're working on. Let's imagine we're doing it on this spanner. So now, because I'm going to talk about MMA or stick welding, this goes into your machine, and then you have this little clasp handle. Now, stick welding is known as stick welding because you use welding sticks. So as I say, with the gas type, you would heat it up and then add your material. This is your material, but it's also your electrode. Now, unlike the other 2 types of welding, MIG and TIG, which require a shielding gas, this is covered in flux. As you might be able to see here, that metal is the actual material you're going to be adding to your weld. It's just got a number on here that refers to tensile strength and different thicknesses and different things. You get many different types of rods, and I don't pretend for a second to know about all the different numbers. I just know the basic things, the basic ones to use for what I would use. I didn't actually choose to have a stick welder because it happened to be on the TIG welder that I was very generously given by one of my subscribers. But it's always a bonus to have it there because it has unique properties that, as I say, the other 2 using gas don't have. So I'll talk about that when I talk about the next machines that do use gas. But just understand that, as I say, fill rod, flux on the outside. You connect this into the handle, and you've got different cutouts, so you can have it at that sort of an angle, you can have it at that angle, you can have it at that angle. So if you're doing like a downhill thing, you can go. But the simple basics of electrical welding is, it is ground, as I say. This has got the other end of the power. So when you connect this to this, what's going to happen is you're going to create a short circuit here, which is going to create heat, which is going to melt this, which will melt the flux with stick welding. And that will then melt into the surface, create the weld, and then the flux solidifies on top of it, and it protects it from oxygen. That's what the shielding gas is doing, it's stopping oxygen getting to the weld. The reason you don't want oxygen to get to your weld is because it will cause porosity, it will cause basically not a strong weld or something you can trust. Also some contamination can happen, so you don't want oxygen getting to your weld. So the flux covers you on that, whereas in the gas does it in other types of welding. That's one of the advantages of stick welding. You can't use gas welders really, as in like MIG welders, outside, because if it's windy, all the gas blows away and you get a terrible weld. Whereas in these, because they've got their own gas, as it were, built in, it means that it can't blow away. So you can use these in the wind, in the desert, and you can even use them underwater with the right type. If you see someone welding underwater, it's always, if you notice, it's this sort of type of welding. There are pros and cons to stick welding. Pros being, doesn't have gas, so it's quite cheap. Another pro is that it doesn't really care about grease or paint or rust or dirt or anything like that. If you need to weld something together, you can, well, you want to clean it up ideally, but this won't necessarily mind you welding through a little bit of surface rust. Whereas in the other types are more susceptible, in some cases very susceptible, for it not to work properly. It's a very good way of getting a lot of material into a weld. So say for instance, if you're welding a giant steel pipe together, they'll chamfer the edges so they've got like a V, and they'll butt them up together, or even slightly apart, and they can fill the gap, and someone will go round and round and round. Basically, if you imagine this is the V, they're going to leave a layer in the middle that they maybe will bridge the gap with, and then they'll put another couple of layers, and then you basically build up layer after layer after layer after layer until you get it flat to the surface. And then you've got one continuous piece of metal basically going throughout, and it's what makes it very, very strong. So it's a basic type of welding, but it has advantages over the other types of welding which you just can't get around, such as welding in windy conditions or welding underwater. One of the other advantages of stick welding, depending on how much you're going to do, how much you're going to use it, because it doesn't need gas, you don't need to rent a bottle or pay for gas or anything like that. So say for instance, I don't know, you just want a basic cheap welder that's going to allow you to quickly weld together a little go-kart frame, a soapbox car, something like that. I would still say go with MIG, because it's the better all-rounder. But if you're doing it outside, you're going to need to use stick. And it, as I say, I'm not going to go into too many details about this, but that's basically what stick welding is. I'll now give you a quick demonstration of this in action. Keeping in mind it will be the second stick weld I've ever done. Now hopefully this should go without saying, you need safety equipment when you're welding. A welding mask. The way these work is they have a solar panel in the top. You can barely see through them, and when you start welding they go even darker, and you can adjust how dark they go by this. The idea being that you can look at the material, see what you're kind of doing, click it, and then it'll darken instantly and you can weld and see what you're doing, because you actually need to be able to see the puddle of metal moving. Also, welding produces UV light, a lot of it. If you look at it directly, you get a thing called arc eye, and it literally burns your retinas. Equally, if your skin isn't covered, it will give you a suntan, and I learned very earlier on not to do that. It was a bad idea. So, you need to cover your skin. Now, you should ideally wear like a welding jacket that's made of leather or something, because you wouldn't want to damage your lovely Spicy 110 t-shirt or hoodie. Available links in the description. But you also don't want to set fire to yourself either. I'll be honest with you, I wear these sorts of hoodies when I'm welding, and I haven't set fire to myself yet, but I can't advise that on YouTube. You have to be super safe. So, welding helmet. You also need gloves. Now, depending on the type of welding you're doing, depends on the type of gloves you'll use. These happen to be TIG gloves. They're very, very thin, very pliable, and it gives me much more dexterity. With TIG you need that, and actually I find that I can weld better with MIG if I've also got that extra dexterity compared to the big gauntlets. But people who are doing sort of stick welding tend to wear much more powerful, much more heavy built gloves because there's a lot of heat going on. There's a lot of spatter and stuff, and equally, these sorts of gloves don't actually last that long. This is kind of funny. Heat makes leather shrink. So look at the length of the finger difference. It's my strong hand. The fingers have shrunk. Let's get the other camera on. Long fingers, little fingers. The heat of holding things and picking things up. I mean, look at it, it's like a claw, it's like a bear claw, has almost destroyed these gloves. They still work, I can still use them, but they're starting to get holes in them. I need to get a new pair soon. But I really love TIG gloves because they're so thin, but they're not as durable. Now, I know what you welders are like, so I'm going to make it clear now. I am probably going to produce some terrible looking awful welds. This is not the point of this video. This is not to teach you how to weld. Do not learn from me how to weld. I'm not that good. And for the first one I'm going to do, the stick welding, this is the second stick I've ever done. Right, so disclaimers aside, so you don't pick on me. Earth bleed on. So stick welding, as I mentioned. Clamps on, doesn't need gas, power's always on. The way this will start, should do, is I'll touch that off the surface and then I'll start running a bead down. So I need to make sure it's in MMA mode. Sorry about the noise of the fans, nothing I can do about that. I'm going to select an amperage. I'm going to go with 69 amps. It's probably too much for this material. It'll probably get too hot. I'll find out. Point is, as mentioned, I'm just showing you what it looks like. Oh, this is what I'm doing now. Too proud. Not enough heat, actually. So as I mentioned, that is only the second time I've used this, and the first time was just one of these and I was just like... So don't expect these to look great. They currently look disgusting, as you will notice, because of all of the slag caused by the flux. I think this goes without saying, welding uses an incredible amount of heat. Don't touch a weld. If you heat, if I'm doing a small item like a cog or something and I've welded something on it, it will be hot and hot enough to burn you for a long while. There is also into that you get problems with distortion and heat distortion in metals and stuff, but that's not for this video. This is the basic stuff. So on my little hammer I have that little metal thing, that's for breaking off slag. So what looks really nasty right now is about to look a lot worse. Should have mentioned, sorry, about the safety equipment. You should also be wearing a respirator, particularly with stuff like that that's producing that much gas. And actually recently they mentioned that you should for TIG welding because of cancer. Everything gives you cancer. As you can see now, the welds look much nicer because I'll show you a close-up after I've done all the different types at the end when we kind of do a roundup, but you can see they look a lot neater than they did before. Okay, so now moving on to MIG welding, otherwise known as metal inert gas, and as I mentioned, this is the first electric type of welding I've talked about that actually uses a gas rather than the flux like on the stick welding. Remember that. Although there is an option to not use gas with a MIG welder, which I'll get onto. So as I say, this is probably one of the most common types of welding you'll see being used in most places. Obviously there's variations in different places of jobs that are different, but this is one of the most ubiquitous, that's the word I'm looking for, types of welders you'll see out there. So just like the stick welding, you need an earth clamp that you attach to the material that you're working on. You also, for this, will have a gas feed, because this needs gas going into the machine. This gas would be carbon dioxide, CO2. You can also use a CO2 argon mix. You can either get that in giant big bottles, medium-sized bottles like this is an argon one, or you can get these expensive little suckers which are disposable gas bottles. You have a little regulator that you screw onto here. It has a little tube that plugs into it that comes out the back of the machine, and you basically just have that next to your machine. So if you're, for instance, I don't know, so you're a mobile mechanic, for instance, and you need to weld a little bit of work on the side of a car, but you want to do it at their place, and it's not too windy, or you've got it protected, then you can very easily take this to the back of your van, or whatever, and use the little mini bottles rather than carrying around a giant bottle. But if you've got a van, normally people take the big bottle with them and have it living in the back of the van. So whatever, but they're the options. As I say, gas is normally CO2, sometimes CO2 with the argon mix. So obviously, like with the gas welding and with the stick welding, you need to add material. Well, the way that MIG works, and one of the reasons why it's really fast, and you might not realise this about these machines, inside them, is this is a giant reel of, I think it's copper-coated steel. It is steel, you know, because you're welding steel, carbon steel, but I think it's got a copper coating on it to try and stop it from rusting. It comes in all different thicknesses and different types depending on what you're welding, but the basic stuff for mild steel is this stuff. So as with the stick welding, as I say, attach the earth, then you'll have power settings and feed rates, and I'll get to that in a minute. One thing I forgot to mention about stick welding is that unless you have a machine which has a trigger on it, they're always on. So all you do to start welding is touch the electrode to the surface, as you will have seen, and it will start welding. With this, you have a button, and the reason you have a button is when you pull that button, this will start turning, and this cable, which is fed through here through a drive roller, comes all the way down the cable and out the front of the machine. Is this on? Yeah, like so. Now I've just got to trim this off. Don't do this to your ground clamp, unless you hate it. And I do hate mine, so the sooner it breaks the better and I can replace it. I was basically using the arc then to cut the wire. So, when you go to weld with MIG, you pull the trigger, the gas starts coming out of the end of here, because that also comes down the hose. It starts pulling around the place that you're welding, and the wire continuously comes out, and that is your electrode. That's what touches the surface, or gets close to the surface and causes the arc, and then that fills in as you go along, which you'll see in the demonstration. Now, there's two things you generally... Now, some machines are a lot more complicated than this. This is like the most basic but decent little welder. This is actually a Wolf 140X. About 170 quid on Amazon, I think. So the two controls on here on the most basic machine is the amount of power it's going to go into the weld and the feed rate of that wire. Now, power is adjusted depending on the thickness of the material you're working on. So if you're welding something very thick, you'll have to put it up to so many amps. This, as 140 amps, if it actually does 140, can only weld up to, I think it suggested about 4 or 5 mil, although you could go a little bit higher, but you couldn't trust the weld necessarily. If you want to go through much thicker stuff, you need much more powerful machines. That's one of the things that stick welding is very good at, is good penetration to make good, strong welds. But for most hobbyists, as it were, and I imagine you would be a hobbyist watching this, because if you're a professional, oh dear God, why are you listening to me? This will cover most of your needs for the basic types of welding you'll need. It's a bit hard to explain, but obviously you need more power, it's going to make noise, more power for the thicker the material, but you also, depending on the job, might need more filler wire. So to get a good combination of those two is how you get a nice looking weld. If you have the filler wire really high and the power really low, it's going to keep trying to push more material in than it hasn't been able to melt, and you're going to end up with a complete mess of spattered stuff everywhere. Equally, if you try and put it up really high and have this really low, the second it comes in contact, it's just going to melt that wire instantly. So it's a bit, in a way, it's a bit like a glue gun. You know, a nice steady pull on the trigger is that it's not trying to melt too much at once, and it gives you a nice smooth flow. That's basically what welding is kind of like, but if you understand glue guns and how they work, you know, if you try and cram before it heats it up, it just gets all blocked up and doesn't work. If it's too hot, because it can get too hot, and you give it the slightest touch, it's everywhere. So, smooth control requires a balance between power and wire speed. This is different for each machine, and for this machine it's different for every day, because this wire feed is, should we say, less than precise. It's a bit sort of, it's not very linear in its adjustments, but I've got used to this machine, and you will get used to your welding machine. There is a lot of learning there to be done, but don't be scared to do it. It's fun. You don't have to like try and weld anything important, just weld some pieces of metal together for fun, see what it's like. But you'll have to get used to adjusting these two things depending. There are charts and things that will help you with that, but whatever. Now, before I show you a quick demonstration of this, I want to talk about why we sometimes pick the different types of welding machines. Technically, you can weld stainless steel, carbon steel, aluminium, all these different things with stick welding. You can also do it with MIG welding, and you can also do it with TIG welding. Yeah, they all do it. But you generally don't, because it's very specialised. So like most people, if they're going to do stainless steel, are going to use a TIG welder, which we'll get onto in a minute. If you're just doing mild steel and you want it to look reasonably neat, or you need to do lots of long welds or something like that, then you're going to go for a MIG welder. And if you want to just get a lot of material down and get things welded together in a quick fashion that you don't need to clean up the surface too much, you use a stick welder. As I say, this doesn't care about rust and surface stuff. This does care a bit. Ideally you want the surface to be clean, but it needs to just basically be clean of most oils and debris. When we get to TIG welding, it's far more sensitive. So although it's perfectly possible to put stainless steel wire in this machine, change your gas from a carbon dioxide to a argon CO2 mix, I think with TIG welding you use pure argon. And if you're doing it with MIG, to get the sput of the arc started, it needs a little bit of non-shielding gas, so that's why they put a bit of CO2 in it. I believe, I might be wrong on that, but I do know that if you're doing stainless steel welding with a MIG welder, you don't use pure argon like you do with TIG welding. So as I say, although it is physically possible to do it, in most cases, stick welding will be used for mild steel, that's carbon steel, and there's a few other variations of that. Equally, it would be used for aluminium and stainless steel in places where they need a big, heavy, strong weld of stainless. And equally, they may do the same with this. But, as I'm saying, as a generalisation, if you're going to be welding mild steel, you will go with stick welding if you're going to be outside, and if it doesn't matter if it's messy, and you're going to use MIG welding if it's going to be, if you can do it inside and if it needs to look a little bit neater, or you have particularly long welds to do, or something like that. On average, if people are going to be welding aluminium or stainless steel, they'll do it with TIG. But obviously there are exceptions to that rule depending on the work that someone's doing. If we're talking about making a very thick stainless steel plate weld onto another very thick stainless steel plate, although you could use a TIG, a very powerful one, I think they would most probably revert to either stick or MIG. As I say, this is getting a little bit complicated. I want to try and keep this basic. Okay, I'll show you a quick close-up of the gun so you understand how this end of it works. So as I mentioned, electricity comes up through and comes out of the steel wire, which is being propelled out the end at varying speeds depending on what you need. The trigger is here. So when you pull the trigger, gas comes up through here and starts coming out of the shroud. This is the shroud. And inside there is a tip which is guiding the middle core. So if we pull this off, there you go, there's the shroud. It's just hollow. These are consumable. They will get little holes and stuff blown in the side of them over time. So these are cheap and you just replace them as and when you need to. Although you can clean them up between use them if you get a bit of, spatter and stuff on them. You can clean them up a bit and prolong their life, but they're not expensive. Then on the end of here, as you can see, this is where the gas comes out. So the gas comes out inside the shroud and comes over the top of the electrode and then comes out onto the weld. So this is a tip. Now, depending on the thickness of wire that you get, if you're using something that's quite thin, you'll use a thinner material. If you need to get a lot of material in, you'll use a lot thicker versions. But basically, this is a tip which is, again, replaceable because they will get damaged over time. It's just a little brass, coppery thing. It's got a hole in it that's just the right size. And we're talking, well, this is 0.6. You also use 0.9, which are like slightly thicker. You just pop that wire through there. That screws in there. Shroud over the top. Tight fit. And there you go. Now, this is a slightly cheap machine, so this is one of the problems. Look, there's a bit of movement. And it's not too difficult to accidentally touch this against here and yeah. On a better machine, that is normally held perfectly centrally like that, doesn't move or wobble. One thing I forgot to mention, and I must mention, is that with MIG welding there is an option to not use gas, and that is flux core wire. This is the filler wire. You can't see it because it's got paper over it, but you get different size reels of the material that you're going to weld with. It's much cheaper when you buy bigger quantities, depending on the size of the spool that your machine will take. As you see, this is the standard steel stuff that needs gas. This has got a flux in it, and it means you don't have to use gas, so it means you can MIG weld outside. However, it doesn't produce the best welds, and it is messy like stick welding. As you can see, this came with my machine. They gave me some normal wire and some flux core, and I've never tried using it, ever. And it's not something you can easily, well, you can easily switch it over, but you have to take your other reel out and wire it in, and you also have to reverse the polarity. Inside my machine, I didn't show you, there is 2 screws with a positive and negative connector, and you just undo them and reverse them if you're using flux core, because you need the positive to be the thing you're welding on and the gun be the negative, whereas normally it's the other way around, generally. More power! I'm actually getting more spatter with this than I am with the sticks. Normally you'd think it'd be the other way around, but I think there's some contaminants on the outside of the fill wire, so that's probably why it's being a bit weird. Plus I've probably got the settings not quite right, so let's do a couple more. That's not right. This is this varying control. Right, okay, I've just wound off what should be what I think is contaminated wire. We'll see if this goes any better. Ah, finally! I think we have found what the problem was. It's starting to look a little bit better. Okay, so this is a pretty bad representation of my MIG welding skills. Yeah, contaminated wire, other problems, but it does go to show how just tiny little things can really affect how well a weld goes. And as I say, with stick welding it can put up with a lot. MIG welding, it can put up with something but not that much. Yeah, look, it's rust. I've got some rust forming for some reason on the outside. I need to put a little wiper in there that will wipe it off. Basically as the wire goes through, you can put something there that will just wipe the outside off and keep it cleaner. Okay, so I've cleaned those up and they still look absolutely terrible. But it is what it is. It kind of shows how imperfections, impurities and stuff can cause problems. Okay, I'm now going to show you TIG welding, and I'm going to show you one of the reasons I love that TIG machine over this in the sort of the home shop size machines. This weighs a ton. It weighs a lot. Here's my TIG welder. Is that a quarter of the weight? Okay, so this is my TIG welder, but it also happens to be my stick welder because that was a function it has built into it. The TIG welding lead comes out this side, and you just basically have an electrical and gas port in one. And this is a separate lead which goes to the trigger on the torch. Obviously on the MIG welder, all of that is inside there, and it's all held inside, but this is a sort of an external switch with this machine anyway. So the ground clamp for both stick welding and TIG welding goes in this socket hole here. I would mention on my MIG welder the leads are attached to the machine, you can't undo them easily, so if you were to damage one it's going to be a little bit more difficult to fix it. But as I say, with this one you basically can plug them in there like bayonet fitting. So the earth is on this side for both types of welding, and you plug your stick welder handle, the clasp, in that hole which is available, and then all you have to do is switch from TIG to MMA. Now this is a very, very, very basic machine, and you'll notice it has numbers on the screen, and depending on what I put it on, it's different amperages for whatever you're welding. All these machines have fans built into them because they get very hot basically, or they can get very hot and overheat the circuitry. So as I say, for this very basic welder, that's all you're going to see. Some TIG welders are super complicated, well not complicated, but have lots and lots of options, lots of different settings, lots of different things, like panels of buttons, which is not really too complicated what they do, but we don't need to go into that too much. But everything else you need to see is on the torch end, so let's switch to that. Okay, so this is a TIG welding torch, but there is something I need to explain now. I may have mentioned this or not. Gas welding is actually very similar to TIG, or TIG is very similar to gas welding in a way. Because unlike with MIG, where, as I said, you know, the filling material comes out the end, this has an electrode. So this is just like a heat torch. You basically apply a plasma focused arc onto the surface of the metal, and that melts the metal. So then you have a filler rod such as this. This is for steel, and it's very long, and obviously you can trim them down. And with TIG welding, you have a button, and the gas comes out here. I'll get onto that in a minute. And basically you heat up the material like you kind of would with a gas welder, and then you add the material like that. So this electrode is not consumed in welding, although it can be damaged and it does need to be replaced regularly, reground. But if you want to learn more about TIG welding, I have a video on setting this up and just the basics of TIG. But I'll just quickly break down the torch so you can understand what's going on inside here. So this is the back cap, and this is just covering. See this? This is a tungsten electrode. TIG, by the way, stands for tungsten inert gas. There's different thicknesses of the tungsten you use in different types. This is thoriated tungsten. You might use lanthanated for other types of welding. On the end here is also a ceramic cap, which allows you to touch that onto the surface without causing an arc. This is a replaceable nozzle, just like in the other machine, the MIG. So the gas and the electricity come up through here, but it's one tube basically. So you have that nozzle that goes on just like on the MIG welder, but then instead of having the filling material go through, you have the electrode, and that's in a thing called a collet. And that basically just clamps down, because you want this to stick out a certain amount outside of this, and that basically helps flow direct the gas, the argon, as it comes out. With TIG welding, it is incredibly important to make sure you've got the right amount of gas, and it needs to be argon 100%. So, as you can see, it's just protruding just a little bit, and when you put this on, I could have just tapped that and it would come out more. This actually clamps it down and stops it from coming out. So when you go to start welding with this, you get close to the surface, you click the button, it floods a load of argon out, then it starts the arc. Now there's a couple of different types of TIG welders. You have scratch start and high frequency. High frequency, basically you can hold the torch off the surface, press the button, and it will jump and it will make that arc and it will start welding straight away. With scratch start, you physically have to touch the two together to start the arc, like with stick welding. You see how I had to start going to get it going. So as I say, imagine this is like the gas torch. You're melting away, adding material, melting, adding. Now the different settings and the different types of TIGs. This, for my very basic one, you put the power setting on what you want, and then when you press the button, you get that power setting. With more expensive, more advanced machines, you get pedal control, which basically means that I think you can select a maximum and a minimum, but you get a variation control between the two. So, whereas where you might, you know, increase the power, decrease the power, increase the power, decrease the power as you're going through a weld or whatever, you can variate that with your foot. With me, I have to do it with movement speed, so that's kind of like my feed rate, but it's not, because this is the feed rate. It's kind of both. Try not to get this too complicated. But for me, for my uses, for what I'm doing, the reason I was so happy that someone sent me this TIG welder, it was a very generous subscriber of mine, was that it allowed me to weld stainless steel, and it's also allowed me to do very small, precise welds. That's the thing that TIG excels at, is precision. Tiny, tiny little spot welds. You don't always have to use filler rod, depending on what you're doing. You can just fusion weld, which is where you basically just melt the surface, well, more just underneath the surface, you know, of the metal, and the heat itself as it dissipates through the metal will weld the two together, and you don't have to add anything. But that only really affects small welds. But this does produce some of the most beautiful looking, most precise welds. You know, if you want quick and dirty and effective, stick welding. If you want the kind of middle ground, then you go for MIG welding. If you need to do really precise, pretty stuff, very small welds, and you want to be able to vary how much material you add more easily as you're going along, then TIG welding is the thing. But equally, it has to be super clean. You can't take some greasy piece of metal and try and TIG weld it. You need to clean it up. Depending on how important that job is, that can be as much cleaning up as using literally alcohol, acetone or something to basically add an alcohol to clean all the grease off to give you the best weld. If you want to weld mild steel, you know, the carbon steels, you can use TIG. It works really well. MIG might be better for you depending on what you're doing. For me, it's great that I've got the option of both. But the major advantage of TIG welding is that you can do stainless steel, as I say, and aluminium. The only thing to mention there is that if you want to do stainless steel, carbon steel, a DC machine like this, DC powered, is absolutely fine. If you want to do aluminium, you need an AC machine, which basically just reverses the polarity. Okay, so TIG, sorry about the noise. This isn't as clean as it should be, but I just want to show you what it looks like, so if you see someone doing this, you know what they're doing, and as I say, you can find out more from there. So that's without filler. Okay. As you can see there, that's contaminants. That's where it's not been cleaned up properly. That's where TIG just does not want to work. Okay, so this discoloration, there is definitely a load of oils and contaminants going on here. Not a good representation of TIG welding and how neat it can be. I've done much neater stuff in this, but I've just wanted to show you what it looks like basically. So let's clean that up a little bit. Because a lot of this didn't go right, these aren't good representations, because I've just grabbed some old piece of scrap which has been used for all sorts, has got grease on it, and I just ran an angle grinder over it. But showing for dirty steel, as you can see, the stick actually did pretty well. Although, as I say, that was the first half of my second MMA stick ever. The MIG started out okay. I think that was the bit of wire that was actually inside the sheath, and it started okay here as well, and the second it got some of the contaminated stuff, from that point onwards it got messier and messier and messier. As you can see, it's getting a right problem here. Also, the feed rate was all over the place, and as I got through to cleaner wire, it started to neaten itself up again, although again, that's too proud. It needs to be flatter than that, but they're not a good representation. Then TIG, trying to TIG on this dirty stuff was a dumb idea. This little fusion weld, as you can see, that's nice and neat, nice and flat. It didn't even want to really take there. Didn't do a lot there either. And it started doing some weird, there's some porosity going on in that one, in that hole. That's probably because of some oils that were there. And these going brown means there's tons of oil. But there you go, that's the main three different types of welding you'll see people doing. You'll be able to recognise what type of welding it is, whether they've got a stick, whether they've got a gun and it's, you know, it's sounding like bacon crackling, or whether it's the continual flow of the TIG welder. Okay, well there you go. I do want to emphasise a point though, which was this video was not about teaching you how to weld. It was basically to take someone who knows nothing about welding, and if they see someone welding, they might have an idea of what they're doing or what type of welding they're doing. Equally, if someone's thinking about taking up welding and wants to try and build something, well, now they might realise that, well, if they're doing it out in the garden, stick welding might be their better option over MIG, but generally MIG is the one that you want. Whereas if you're wanting to do really fine stuff, then TIG's better. It's just pointing out what different processes there are. And obviously there are many processes and variations and different things you can do, but I want to talk about it in the terms of your everyday hobbyist rather than your specialist, because frankly, if you're a specialist and you know a lot about welding, I don't know why you're watching this video. Anyway, thanks for watching. If you feel like supporting this channel, please do. I have an Etsy store where I sell things that are welded when they are much better than that. There's also Patreon if you feel like joining it, and there's merch and stuff as I previously mentioned. There you go. If you got any questions, drop them below. Am I going to hang myself over those MIG welds? Yes. I'm just finding some rope as we speak. If you enjoyed this video and the other content on the channel, please consider following the links in the description to show your support.